All right, let's look at part B. This is the definite integral from 0 to 1, 1 over 25x squared plus 1 and square root. So it looks to me that this is the sum of the squares, but we have to write it carefully. So integral from 0 to 1, 1 over radical 25x squared is the square of 5x, right? And then 1 is the square of 1 itself, right? And dx. So now I have the sum of the squares. And what I'm going to do is just to go back to the table where we have the derivatives and integrals involving inverse hyperbolic functions. And I would like to grab a relevant formula out of this, okay? So it looks to me that number 1 in the list is the most appropriate, because we have the exact same form, but all we need to do is just to call u first and call a as well, and then see what we get at the end. So what I'm going to do now is to call u to be 5x to start with, so that du becomes 5 dx, and convert this integral to the u version of that. But be careful, we don't attack definite integrals right away. So what I'm going to do is just to erase this part and rewrite this integral without its limits, okay? So you have 1 over 5x squared plus 1 squared. This is radical, right? And now I'm going to do the u substitution here, okay? So u equals 5x and a equals 1. In the meantime, I'm just preparing myself for the formula. And du is coming out of this as like 5 dx, right? So now this integral is turned into 1/5 du divided by u squared plus 1 squared. I can also pull out 1 over 5. Here we go, du over u squared plus 1 squared, but 1 is our a, so why don't I write it exactly same as what we had in that table here, right? So I'm going to use the plus version here, so I'll go with the plus version. There we go. And this integral is equal to ln of u plus u squared plus a squared. Okay, ln of u plus u squared plus a squared and plus c. Okay, I should probably move over a little bit. Okay, plus c. All right, good. Let's plug the u guy and a guy back. So ln of u is 5x, 25x squared plus 1 plus c. All right, so we're almost done, right? So what I'm going to do is now applying the fundamental theorem of calculus for this function. So 1/5 ln 5x plus 25x squared plus 1. And I'm going to use the bracket here, okay, from 0 to 1. All right, let's see what we have here. 1/5, plugging in 1 for x yields ln 5 plus 25, 26, right? Radical 26 minus 1/5. If you plug in 0 for x, you have ln 0 plus radical 0 plus 1. And that is ln 1, right? And ln 1, as you may remember from calculus, is equal to 0. Okay? So then if you want, you can go ahead and find a decimal number, a number with decimal places for this one, or just leave it as is, and this is the final result, which is the value of this definite integral. Like in part A, I'm going to sort of like relate this to an area concept because the given function is non-negative, right? So the graph of that should be about the x-axis. And please go ahead now with your TI-84, plot the graph of 1 over radical 25x squared plus 1. And you can put your x min to be 0, x max to be 1. And please pause the video at this moment and work through that. And what you're going to see in the graph is this. Okay, so you have the blue curve which is the graph of 1 over radical 25 x squared plus 1, okay? And then you have the x-axis, in other words, y equals 0. And now I have the green area, okay? I have the green area here, which is stuck in between 0 and 1, right? Let me just write here, 0 and 1. So we have this green region, so the question is like, what is the area of this region, okay? So you may have been asked this question so that you would still calculate this integral, okay? So this is in fact now the area of this region, right? All right, so that area turns out to be ln, 1/5 ln, 5 plus radical 26. Again, go ahead and use your TI-84 to get a number with decimal places. All right, I think we took care of both part A and part B, and we are completely done. So I'm going to finish this video right now, but please practice these formulas on your own and see the different versions of these questions and try to practice with them. And also practice these derivative formulas in terms of antiderivatives or in terms of integrals. All right. Please send your questions and comments to my way, and I'll see you in another video. Bye.